Okay, this is group 15. Today we're going to do the video demonstration of the final project. Okay, first of all, let's start with the declaration of integers and entity. So let the entity be IDU, stand for integer division unit, integer divider unit, sorry. Okay, and first of all, clock and reset n. A and B. A is the dividend and B is the divisor, and quotient and remainder, which are the standard logic vector, and error and done. And for this is we assign the total bit width of the vector to be 8-bit. Then Y is the state type or the current state. Q and R be an unsigned value of n down to 0, n minus 1 down to 0, and A2 B2 be a copy of A and B. L and D is stand for load and done. Then for the transition process, if reset n equals to 0, the current state Y is still S0. Otherwise, if the clock is positive age triggered, we partition into 3 subcases. First case is when the current state Y is S0. This is initialization state. So assign A2 be A, B2 be B, R be unsigned A, Q be a full 8-bit of 0. And if unsigned A is more than B2 and B2 not equal to 0, then Y will go to S1, else Y will go to S2. When current state Y is S1, the R is minus by unsigned B2, Q will be plus by 1. If R minus unsigned B2 is still greater than B2 itself, Y will stay at S1, otherwise Y will go to S2, and for S2 this is output result. The remainder be relative remainder be R, quotient be Q, and if unsigned A not equal to A2 and unsigned B not equal to B2, then Y will go to S0, the initialization state, otherwise Y will stay in S2. And the transition process, this is the output process. So L, D, done, error, let L be 1 and D, done, and error be 0. And partition into 3 subcases. When the current state is Y is S0, let L be 1. If the B is equal to 0, raise the error to be 1. When S1 D assign 1 to D, when S2 assign done to assign 1 to done. Okay, next is the test case code. Okay, all the component and parameter declaration, nothing. We draw a function from IDU or the final .vhdl code, and we partition for the test bench, we partition into 5 subcases. The first case is the division with no remainder. The second case is division with remainder. Third case is when the dividend is greater than the divisor, 3 is more than 7. Fourth case is when the dividend is 0, and third case is when the divisor is 0, which should trigger error. Let's see the waveform. Okay, you can see these are all the wave. I mean, you see, first of all, this is the time when the code is at the initialization state. Now this is when the waveform is in the first case, the division with no remainder. This is when the waveform is in the second cases, the division with remainder. This is the third cases, the dividend less than the divisor. This is the fourth cases, the dividend is equal to 0, and this is the third cases, the divisor equal to 0, we should trigger error. Alright, thank you very much. Bye bye.